Hi students, in this video I will explain how to find the solutions of homogeneous differential equation. This topic for those students in A-level math class. Okay, I will begin with the introductions. What is the homogeneous differential equation? Look at this. If an equation dx y dx a differential equation, differential functions, and q x and y dy 0. These equations we may state as homogeneous differential equations if pxy and pxy have same order and homogeneous. Again, if px and y and px, y is homogeneous and have same order. Okay. And if the condition like that, so these equations include of homogeneous differential equation. So how to find the solutions of homogeneous differential equations? Through substitution. Substitution this. If phi equal y over x, it means y equal, it means we may state that y equal phi times x. Okay, and then dy equal phi times dx plus x times dv. It is. And the implications are the functions p x, this differential equation becomes pxy becomes p x comma phi x, because y equal phi x this, and the homogeneous differential equations becomes x or m x power m times r phi. R phi is differentiations of p. Okay. And how about q? Qx or y becomes q x comma phi x, because y equal phi x, and the solutions x power m times s phi. S phi is differentiations of q. Okay, let's discuss three problems. I have provided three problems for our discussion through this video. This one, we're going to find the solutions of these differential equations. First off, I will simplify dy times 3x y squared, I mean, it becomes 3xy squared dy is equal 3y cubed minus x cubed dx, like this. And afterwards, the next step, we may write down 3y cubed dx minus x cubed dx minus 3x y squared dy equal 0. Okay, so look at this differential equations is differential equations third order, homogeneous differential equation third order. Okay, now let's we substitute y equal vx and dy equal v dx plus x dv. Okay. These equations, these equations, if you substitute this statement y, this equation y equal vx and the y equal v dx plus x dv, this equation is going to be 3 y cubed, it means v cubed x cubed dx is 3, not 5, minus x cubed dx minus 3x times v squared x squared dy v dx plus x dv. X dv equals 0 afterwards divided by x cubed. If divided by x cubed, it becomes, yeah, it becomes 3 v cubed dx minus dx minus 3 v multiply with in brackets 3 v squared dx minus 3 v squared 3 v cubed here. Sorry, this one not square but cube. V squared times v, and this one 3 v squared x. dv equals 0. Okay. And afterwards, look, this one we may calculate, it becomes 0. And times -1, times -1, it becomes dx plus 3 v squared x dv equals 0. Okay, and the next step divided by x. If divided by x, it becomes dx over x, and it becomes 3v squared over x dv equals 0. dv over x equal this one x, yeah. No need to write down this one 3v squared dv, I mean. And if integration, it becomes ln x plus v cubed equal c. Okay, I call that v equal y over x. So these equations we may write them like this. Ln x y cubed over x cubed equals c. And if you multiply by x cubed, it becomes x cubed ln x plus y cubed plus x cubed times c. This. And we may simplify, becomes y cubed equal x cubed c minus x cubed ln x, or y cubed equal x cubed times c minus ln x. This is the solutions of this differential equation. Okay, let's move to the next problem. Find the solution of these differential equations through substitutions. Y equal v times x, or v equal y over x, and dy equal v dx plus x dv. Okay. The first step, we will simplify these equations. Are going to be dy equal, I'm going to write down this one as phi, this one, phi minus cotangent phi dx. Like this. They call that dy equal phi dx plus x dv. So we may writing phi dx plus x dv equal phi dx minus cotangent phi dx. Okay, and it becomes 0. So this equation is going to be x dv equal minus cotangent phi dx. Yeah. So very simple to simplification these equations. Gonna be this one, these equations, and move these terms move to the right side, and it becomes, I'm gonna write thing like this, x dphi plus cotangent phi dx equals 0. Okay, and afterwards I will, yeah, this cotangent, the cotangent is cosine over sine. Yeah. And now I'll divide it by x, divided by x times cotangent phi. Yeah. Why we should divide it by x times cotangent phi? Because look, the implication becomes the phi over cotangent phi. Yeah. And dx over x. So phi and phi, x and x. Cotangent becomes cosine over sine, so it becomes sine phi d phi over cosine phi. And this one dx over x equals 0. One tangent sine phi over cosine phi is tangent, so we may, if we give integrations, it becomes integration tangent phi d phi plus integration dx over x equal 0. Cotangent, now we are going to find integration tangent phi, and integrations 1 over x, and it becomes integration tangent phi equal ln cos phi. Okay, integration 1 over x equal ln x. Okay, equal c. I'm gonna move here. In this space, and we may write down ln cos x, ln cos phi, I mean, equal ln c. Recall that c is constant number, so we may writing as ln c, minus ln x. So ln cos phi equal ln c over x, or cos phi equal c over x. Phi is y over x, so the solution is cos y over x equal c over x, like this. Yeah, so it's very simple. This is the solution. Let's move to the next problem. This one. Of course, firstly I will simplify, and it becomes dy equal 1 plus, this is phi, minus cos square phi, cos y over x dx, like this. And recall that dy is x dv plus phi dx. Okay, equal dx plus phi dx minus cos square phi dx. It becomes 0. So x dv, okay, x dv equal dx minus cos square phi dx. Or we may simplify, it becomes x dv 1 minus cos square phi dx, like this. 1 minus cos square phi equal sine square phi. X dv minus sine square phi dx equals 0. Okay, afterwards, we give integration here. Okay, and integrations x, it becomes a half x squared. Yeah, integrations, okay. Phi dx, not yet. Wait. We have to simplify first. We have to divide first, because x dv and phi dx. So we cannot find the solutions if we give integration. So we will divide it by x times sine square phi. So it becomes dv over sine square phi minus dx over x equals 0. Afterwards, give integration like this, and it becomes, I will simplify this integrations. The denominator will divided by cos square x, while the numerator will divided by cos square x as well. So it becomes better if I writing here integration dv over sine squared phi equal 1 over cos squared phi over sine squared phi over cos squared phi dv. Yeah, like this. And sine squared cos squared is this is tangent. So it becomes integration 1 over cos squared phi over tangent squared phi dv. Okay, if u, I will using another substitutions. If u equal tangent phi is sine phi over cosine phi. Through quotient rule in differentiations, we may find du equal 1 over cos squared phi. Yeah, through quotient rule in differentiation. So it means these integrations we may writing 1 over cos squared phi dv is du, so it becomes du over u squared. Okay, so it means yeah, and yeah, the integrations of dv, yeah, u equal this one. So integrations of this dv over sine squared phi, it becomes integrations du, while u is sine phi over cos phi. Yeah. And it becomes ln u wait, not ln u, but -2 plus 1, -2 plus 1. -2 plus 1 equal negative u power -1 here, or -1 over u is tangent phi, tangent phi plus c, of course. Okay. Tangent phi is tangent y over x. So this integration is going to be, the outcomes is negative 1 over tangent phi or tangent y over x, like this, minus, this is ln x, well, c, like this. And we may write down, this one becomes tangent sine over cos, it becomes minus cos y over x, okay. Sine y over x equal c. Yeah. Or we may writing minus cotangent y over x, this equal this one negative ln x, move to the right side, becomes plus ln x like this. And if we multiply by negative 1, it becomes cotangent y over x equal c minus ln x. So this is the solution of this homogeneous differential equation. Okay, this is for your exercise, students. Find the solution of these differential equations, homogeneous differential equations. If you have a problem how to find the solutions of it, or if you have any questions regarding these explanations, you may send me your message through this email, hendrik.academy21@gmail.com. Thank you for some students and 2 teachers already send me your email, ask me and request me several topics, several important topics for their preparations and for their understanding. Yeah. Thank you for joining with me in this lesson. See you